The morning of July 24th, 1943, Lieutenant Commander Lawrence Daspit stood at the periscope of USS Tinosa, watching the largest tanker in the Japanese merchant fleet steam directly toward his position. Tonan Maru Number 3, 19,262 tons, dead ahead, unescorted, making 30 knots on a predictable course from Palau to Truk. American code breakers had put Tinosa in perfect position. Daspit had spent the night maneuvering his submarine, calculating angles, preparing for the textbook attack every submarine commander dreams about. This was the kind of target that could change a patrol from mediocre to legendary. One ship sunk, one massive blow to Japan's fuel supply, one entry in the War Patrol report that would make admirals smile. Daspit ordered battle stations. His crew moved to their positions with practiced efficiency. They had been training for this moment since commissioning 6 months earlier. The torpedo room crew checked each Mark 14 torpedo carefully. The weapons gleamed under harsh electric light, 3,000 pounds each. 46 knots, range over 4 miles, warhead packed with 680 pounds of Torpex explosive, the most advanced torpedoes in any navy. At 09:28 hours, Daspit fired 4 torpedoes. The weapons left their tubes with familiar hydraulic thumps. He watched through the periscope as white wakes streaked across blue Pacific water toward the tanker. 30 seconds. The sonarman heard impacts. 4 distinct thuds transmitted through the water, metal striking metal, the sound every submarine commander wants to hear. 2 explosions followed. Muted rumbles felt through Tinosa's hull. The crew cheered. Direct hits on the port quarter. Smoke billowed from the tanker's stern. The massive vessel shuddered, took a list to port, settled lower in the water. Her engines stopped. She was dead in the water, crippled, helpless, but she wasn't sinking. Daspit studied the tanker through his periscope. The damage was visible, but not catastrophic. The ship's watertight compartments were holding. Her crew was running across the decks, manning machine guns, scanning for the submarine that had attacked them. The tanker fired her 4-inch gun blindly at the water where torpedo wakes had originated. Daspit made his decision. He would finish her. 2 more torpedoes. Both hit, both exploded. The tanker listed further but stayed afloat. Daspit surfaced and began pursuit. The race lasted all night. Tinosa's diesel engines pushed her through darkness, maintaining visual contact with the damaged tanker, limping toward safety. By dawn, on July 25th, Daspit was back in position. He ordered his torpedo room crew to inspect every remaining weapon. Each torpedo was examined, depth settings checked, exploders tested, firing mechanisms verified. Everything appeared perfect. Each weapon was ready to function exactly as designed. Daspit positioned Tinosa at 875 yards, directly off the tanker's beam. 90-degree angle, the perfect firing solution. Everything by the textbook, the kind of setup that instructors at submarine school used as examples of ideal tactics. At 09:30 hours, Tinosa fired her 7th torpedo. The wake ran true. Straight line across flat, calm water. Direct hit on the starboard side. Daspit saw the splash, heard the thud through the hull, no explosion. The torpedo was a dud. He fired an 8th torpedo. Same result. Hit, no explosion. A 9th torpedo. Hit, no explosion. A 10th torpedo. Hit, no explosion. Daspit moved Tinosa around the motionless tanker, checking for anti-torpedo nets for any defensive measures that might explain what was happening. He found nothing. The tanker sat alone in open water, defenseless except for small arms fire from her deck crew. They were shooting at his periscope with rifles and machine guns. Bullets snapped across the water. Daspit ignored them. An 11th torpedo. This one hit well aft on the port side. Daspit watched it strike, watched the splash, then watched something he could barely believe. The torpedo took a sharp right turn after impact, jumped clear of the water about 100 feet from the tanker's stern, tumbled through the air, splashed back down, sank without exploding. "I find it hard to convince myself that I saw this," Daspit would write in his patrol report. He had already decided to save 1 torpedo, to bring it back to Pearl Harbor for examination. Something was catastrophically wrong with the Mark 14, and he needed physical evidence. But he had 4 more torpedoes loaded, 4 more chances to sink this sitting target. Torpedo 12, hit, no explosion. Torpedo 13, hit, no explosion. Torpedo 14, hit, no explosion. Torpedo 15, hit, no explosion. At 11:48 hours, a Japanese destroyer appeared on the horizon. Daspit took Tinosa deep. The destroyer dropped depth charges. None came close. Daspit maneuvered away. When he surfaced hours later, the tanker was still afloat, still limping toward Truk. The biggest target Daspit would ever have was escaping. He radioed Pearl Harbor, requested another submarine be sent to finish the tanker. Then he set course for Hawaii. 15 torpedoes fired, 13 confirmed hits, 2 explosions, 0 ships sunk. The patrol that should have made his career had become a nightmare of mechanical failure. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. 4 days later, Tinosa arrived at Pearl Harbor. Daspit climbed out of his submarine and walked directly to submarine headquarters. He carried his patrol report. His face was drawn. He had not slept properly in days. He expected to be court-martialed, expected to be relieved of command, expected to be blamed for the greatest torpedo failure in submarine warfare history. Rear Admiral Charles Lockwood was waiting. Lockwood was Commander Submarine's Pacific Fleet, 52 years old, a career submarine officer who had commanded his first submarine, A2, in 1914. He had spent 29 years in submarines. He understood the silent service better than almost anyone in the Navy. Lockwood expected rage, expected profanity, expected Daspit to damn him, damn the Bureau of Ordnance, damn the Newport Torpedo Station, damn everyone responsible for the Mark 14 torpedo. 19,000-ton tankers don't grow on trees. Instead, Daspit spoke calmly, methodically. He described each torpedo fired, each hit observed, each failure documented. He explained his decision to save the 16th torpedo. He handed over his patrol report. The document was meticulous. Tims, ranges, angles, witness statements from crew members, everything documented with scientific precision. Lockwood read it in silence. When he finished, he looked at Daspit and said 3 words: "We'll fix this." The Mark 14 torpedo scandal had been building since December 7, 1941. 7 days after Pearl Harbor, USS Sago found a Japanese tanker off the Philippines. Commander Tyrell Jacobs positioned his submarine carefully, fired one of the state-of-the-art Mark 14s, watched it run straight and true, watched it detonate 450 yards short of the target. The premature explosion did no damage. Jacobs had worked with the Bureau of Ordnance, developing the Mark 14. He knew the weapon's design better than most submarine commanders. He suspected immediately that the magnetic exploder was faulty. He deactivated the magnetic exploders on all remaining torpedoes, then continued his patrol, fired 13 more torpedoes at 6 different targets. None hit, 0 ships damaged, 0 ships sunk. Jacobs broke radio silence, reported to his commander that the torpedoes were either running too deep or the contact exploders weren't working. Probably both. His reward for this insight was a reprimand. The Bureau of Ordnance sent an inspector to examine Sago's remaining torpedoes. The inspector found nothing wrong with maintenance or procedures. He submitted a report blaming the crew for improper handling. Similar reports came from other submarines throughout 1942. USS Seawolf, USS Skipjack, USS Sculpin, USS Spearfish. Commanders fired torpedoes at perfect targets under ideal conditions. Watch them miss, watch them explode prematurely, watch them strike targets without detonating. Each commander filed detailed reports. Each report was dismissed by the Bureau of Ordnance. The Bureau's position was clear. The Mark 14 was the most sophisticated torpedo ever designed. It had been developed over 10 years. It incorporated cutting-edge technology. It cost $10,000 per unit, approximately $170,000 in today's money. Nothing was wrong with the weapon. The problem was operator error. Submarine commanders weren't maintaining the torpedoes properly, weren't calculating firing solutions correctly, weren't following procedures, but Admiral Lockwood was listening. In May 1942, he had been appointed Commander Submarines Southwest Pacific, based in Fremantle, Australia. His submarines operated under General Douglas MacArthur's command. His captains reported the same torpedo failures. Perfect setups, perfect angles, perfect range, no results. Lockwood decided to conduct an unauthorized test. On June 20, 1942, he ordered USS Skipjack to Frenchman Bay, near Albany, Western Australia. A fishing net was suspended underwater at a specific depth. Skipjack fired a single Mark 14 with an exercise head. The torpedo was set to run at 10 feet depth. The torpedo cut through the net at 25 feet, 15 feet deeper than set. The next day, Skipjack fired 2 more torpedoes, both set at 10 feet. Both cut the net at 21 feet, 11 feet deeper than set. The depth control mechanism was defective. Every Mark 14 in the Pacific Fleet was running deeper than intended. They were passing harmlessly under their targets. Lockwood sent his findings to Washington. The Bureau of Ordnance replied that no reliable conclusions could be drawn from his test. The test methodology was flawed. The measurements were inaccurate. The fishing net method was not scientifically valid. Lockwood should focus on training his submarine commanders instead of conducting amateur experiments. But Lockwood had evidence. He had documented proof. He sent copies of his report to Admiral Ernest King, Chief of Naval Operations. King was the most powerful officer in the United States Navy. He reported directly to President Roosevelt. He controlled all naval operations worldwide, and he had no patience for bureaucratic obstruction. King ordered the Bureau of Ordnance to conduct official tests. In August 1942, the Bureau finally admitted what Lockwood had proven 3 months earlier. The Mark 14 ran 11 feet deeper than set. The cause was the hydrostatic sensor that measured depth. The sensor was positioned incorrectly on the torpedo body. Water pressure readings were affected by hydrodynamic forces as the torpedo moved through water. The faster the torpedo ran, the more inaccurate the depth measurement became. The fix was relatively simple. Relocate the sensor to the mid-body of the torpedo where hydrodynamic effects were minimized. Recalibrate the depth control valve. By September 1942, submarines began receiving corrected torpedoes. Submarine commanders adjusted their depth settings. Their hit percentages improved slightly, but the sinkings didn't increase. Torpedoes were hitting targets more often, but they still weren't exploding properly. Some detonated prematurely. Some struck targets and failed to detonate. The depth problem had masked 2 other problems that were now becoming obvious. The second problem was the magnetic influence exploder. This was the Mark 6 exploder's secret weapon, the device that supposedly made American torpedoes superior to every other Navy's torpedoes. The innovation that would revolutionize naval warfare. The concept was elegant. A torpedo running underneath a ship's keel would trigger a magnetic sensor. The sensor would detect the steel hull's effect on Earth's magnetic field. The exploder would detonate the warhead directly beneath the keel where there was no armor. The explosion's upward force would break the ship's back. One torpedo could sink a battleship. The British had developed magnetic exploders in World War I. The Germans had developed them between the wars. Both nations had encountered similar problems. Earth's magnetic field varied by latitude. It varied by geographic location. It varied based on local magnetic anomalies in the ocean floor. It varied based on the ship's heading. It varied based on whether the ship was in shallow or deep water. The American Mark 6 magnetic exploder had been developed in the late 1920s. Only 2 test firings were ever conducted. Both tests occurred in June 1926 off Newport, Rhode Island. The target was a derelict submarine. The first torpedo ran under the target and failed to detonate. The second torpedo exploded and sank the submarine, a 50% success rate. The Bureau of Ordnance declared the weapon operational. No further testing was conducted. No tests in different magnetic latitudes. No tests in tropical waters. No tests near the equator. No tests in the Western Pacific where the war would actually be fought. No tests with different ship sizes or different ship headings. The magnetic exploder was classified top secret, so secret that maintenance manuals were written but never printed. Submarine commanders received no training on how the device worked. Torpedo mechanics received minimal information. The secrecy was supposed to prevent enemies from learning about America's technological advantage. The secrecy also prevented anyone from discovering that the magnetic exploder didn't work. In April 1943, Lieutenant Commander John Scott in USS Tinosa found himself in perfect position to attack 3 Japanese aircraft carriers. Hyo, Junyo, and Taiyo, range 880 yards, Scott fired all 10 torpedo tubes. He heard 7 explosions. Sonar confirmed 7 hits, not one carrier, diminished speed. Post-war intelligence revealed all 7 torpedoes had exploded prematurely. The magnetic exploders had triggered too early. The explosions occurred far enough from the carriers to cause no significant damage. 3 days later, USS Pompano attacked carrier Shokaku. 6 torpedoes fired. At least 3 premature explosions. The carrier escaped undamaged. On June 10, 1943, USS Trigger attacked carrier Hio. 6 torpedoes fired, 2 clean misses, 1 premature detonation, 1 hit that failed to explode, 2 hits unconfirmed. The carrier survived. The pattern was clear. The magnetic exploder was hypersensitive. It was detonating torpedoes before they reached their targets. In equatorial waters, Earth's magnetic field flattened into a thick, horizontal disk rather than a vertical hemisphere. Torpedoes entering this field from below triggered prematurely. The explosion occurred too far from the target to inflict damage. Admiral Lockwood flew to Washington in June 1943. He met with his old friend, Admiral Richard Edwards, Admiral King's Chief of Staff. He met with Vice Admiral William Blandy, Chief of the Bureau of Ordnance. The meetings were tense. Blandy believed Lockwood was trying to discredit the Bureau. Lockwood insisted he was trying to save American lives and sink Japanese ships. On June 24, 1943, Admiral Chester Nimitz, Commander-in-Chief, Pacific Fleet, issued an order. All submarines in the Pacific Fleet would deactivate their magnetic exploders. The Mark 14 would use only the contact exploder from now on. The contact exploder would detonate the warhead when the torpedo physically struck the target's hull. Problem solved. Or so everyone thought. USS Tinosa left Midway on July 7, 1943. Her magnetic exploders had been deactivated per Admiral Nimitz's order. Commander Daspit had every reason to believe his torpedoes would function properly. The depth problem had been fixed. The magnetic exploder had been turned off. The contact exploder was a simple mechanical device, a firing pin, a spring, a premier, basic physics. The torpedo hits the target. Deceleration forces drive the firing pin forward. The pin strikes the primer. The primer ignites the warhead. Nothing complicated. Nothing that should fail. 17 days later, Daspit proved that assumption catastrophically wrong. When Tinosa arrived at Pearl Harbor on August 4, 1943, the saved 16th torpedo was brought to the submarine base torpedo shop. Experts examined it thoroughly. They found nothing wrong. Every component was within specifications. The exploder was properly assembled. The firing pin moved freely. The spring had correct tension. The primer was properly seated. The torpedo was in perfect working order, which meant 13 other torpedoes in perfect working order had hit a stationary target and failed to explode. Admiral Lockwood ordered new tests. Commander Charles Lockwood suggested using live warheads, fire torpedoes at the vertical cliffs off Kahulawe Island. Any torpedo that failed to detonate could be carefully recovered and examined. The first torpedo that became a dud would reveal what was wrong. On August 31, 1943, USS Muscalunga fired torpedoes at the cliffs. The second torpedo struck the rock face and failed to detonate. Divers recovered it carefully. The warhead contained 680 pounds of Torpex explosive. One wrong move would vaporize everyone within 100 yards. Momsen personally supervised the recovery. The torpedo was brought to shore and carefully disassembled. The problem was found immediately. The firing pin guide was bent. The deceleration forces from impact had distorted the guide mechanism. The bent guide prevented the firing pin from traveling fast enough to strike the primer with sufficient force. The dent in the primer was barely visible, not nearly deep enough to ignite the explosive. The torpedo designers had made a fundamental error. They had based the Mark VI exploder design on the Mark III exploder used in earlier torpedoes. The Mark III worked fine in the Mark X torpedo, which ran at 30 knots, but the Mark XIV ran at 46 knots. Higher speed meant greater deceleration forces when the torpedo hit a target. The firing pin mechanism couldn't handle those forces. The designers apparently recognized this problem during development. They added a stronger spring to overcome the binding. But as the torpedo's maximum speed increased, the stronger spring wasn't enough. No live fire tests were ever conducted. No one fired a Mark 14 with a live warhead at an actual target to see if it would explode. The weapon went into production and frontline service without anyone knowing it was fundamentally flawed. The irony was brutal. A 90-degree broadside hit, the perfect shot as taught in every submarine warfare manual, created maximum deceleration forces. Maximum deceleration meant maximum binding of the firing pin. The better the shot, the less likely the torpedo would explode. Most successful attacks in 1942 and early 1943 came from torpedoes fired at oblique angles, glancing hits that reduced deceleration forces enough for the firing pin to function. Submarine commanders had been taught for years that oblique shots were second-rate tactics. Broadside shots were the gold standard. Now they learned that oblique shots were actually more likely to sink ships. Everything they knew about torpedo tactics was backwards. The solution was elegant. Make the firing pin lighter. Use a low-mass firing pin that required less force to overcome inertial binding. The submarine base workshop at Pearl Harbor began designing new firing pins. They needed lightweight metal with high strength. They found it in the propeller blades of Japanese aircraft shot down during the Pearl Harbor attack. The aluminum alloy was perfect, light enough to reduce binding, strong enough to withstand impact forces. The irony was not lost on anyone. American submarines would sink Japanese ships using technology salvaged from Japanese aircraft that had attacked Pearl Harbor. The enemy had provided the solution to defeat themselves. By September 1943, new lightweight firing pins were being manufactured. The Bureau of Ordnance also developed an electric detonator with a ball switch mechanism. This eliminated the mechanical firing pin entirely. Both solutions worked. Submarines began receiving retrofitted torpedoes. But 2 years had passed since Pearl Harbor. 2 years of submarine patrols hampered by defective weapons. 2 years of missed opportunities. 2 years of Japanese ships that should have been sunk sailing safely past American torpedoes. In 1942, Pacific Fleet submarines had fired 1,442 torpedoes. Official reports claimed 211 ships sunk, totaling 1.3 million tons. Post-war analysis of Japanese records revealed the truth. 109 ships actually sunk, 41,871 tons, less than 4% of what submarines should have accomplished with working torpedoes. The human cost was equally devastating. Submarine crews had risked their lives launching attacks that had no chance of success. Some submarines had been lost because faulty torpedoes failed to sink enemy escort vessels. USS Trigger had attacked a Japanese convoy on November 10, 1942. Her torpedoes failed. The convoy's escorts counterattacked. Trigger barely escaped. Other submarines weren't as lucky. The strategic cost was immeasurable. Japanese merchant shipping had continued flowing throughout 1942 and 1943. Oil from the Dutch East Indies, rubber from Malaya, food from Southeast Asia, iron ore from China. Japanese factories continued producing weapons. Japanese armies continued fighting. The war continued because American submarines couldn't sink the ships supplying Japan's war machine. But in September 1943, everything changed. The fixes were complete, all 3 problems solved, depth control corrected, magnetic exploder deactivated, contact exploder redesigned. For the first time since Pearl Harbor, American submarines carried reliable torpedoes, and the Japanese had no idea what was about to hit them. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The transformation was immediate and devastating. In October 1943, USS Wahoo, under Commander Dudley Morton, penetrated the Sea of Japan. Her torpedoes worked as she sank 4 ships, totaling 13,000 tons in a single patrol. USS Harder, under Commander Samuel Dealey, began her legendary career. 5 Japanese destroyers sunk in her first year of operations. USS Tang, under Commander Richard O'Kane, started sinking everything she encountered. The statistics tell the story. In 1942, American submarines sank 109 Japanese ships. In 1943, the number rose to 284. In 1944, with fully functional torpedoes, American submarines sank 603 Japanese ships. Over 500,000 tons of merchant shipping sent to the bottom every month. Japan's maritime supply lines were bleeding to death. The Japanese never fully understood what had changed. They knew American submarine attacks were becoming more effective. They observed that torpedoes which had frequently malfunctioned in 1942 and 1943 were now exploding with devastating reliability. But Japanese intelligence never determined the specific nature of the American torpedo problems or when they had been fixed. Japanese merchant captains reported torpedoes striking their ships and failing to explode. These reports came predominantly from 1942 and early 1943. By late 1943, such reports stopped. Ships hit by American torpedoes simply sank. But the Imperial Japanese Navy never analyzed the pattern, never realized that American torpedoes had been systematically unreliable and were now systematically deadly. Part of this blindness came from Japanese doctrine. The Imperial Japanese Navy had never prioritized anti-submarine warfare. They believed submarines were weapons for attacking enemy warships, not commerce raiders. They devoted minimal resources to convoy protection. Escort vessels were few and poorly equipped. Sonar was primitive. Depth charges were in short supply. Anti-submarine tactics were barely developed. When Japanese merchant losses began escalating in 1944, the Navy struggled to respond. They implemented convoy systems too late and too poorly organized. Escort commanders lacked training, ships sailed with inadequate protection. American submarine commanders described Japanese convoys as poorly defended compared to German U-boat opposition in the Atlantic. The result was slaughter. USS Flasher sank 3 large tankers in a single attack on December 22, 1944, over 33,000 tons of shipping destroyed. USS Barb, under Commander Eugene Fluckey, became legendary for aggressive attacks. She once surfaced and used her deck gun to destroy an entire anchored convoy. USS Archerfish sank the carrier Shinano on November 29, 1944. Shinano was the largest warship ever sunk by a submarine. 72,000 tons sent to the bottom with 4 torpedo hits. By January 1945, Japan's merchant marine was effectively destroyed. Ships that had carried 6 million tons of cargo in 1941 could now carry only 320,000 tons. Most of that capacity sat in port, unable to sail because submarine-infested waters made every voyage a death sentence. Oil imports from the Dutch East Indies stopped completely. Refineries shut down. Aircraft couldn't fly. Ships couldn't sail. Tanks couldn't move. The Imperial Japanese cabinet reported to the National Diet after the war that the greatest cause of defeat was the loss of shipping. Not the atomic bombs, not the conventional bombing campaign, not the island-hopping offensive, the loss of shipping. American submarines strangled Japan's economy and military simultaneously. The war ended not because Japan was invaded, but because Japan couldn't continue fighting without supplies. Of the 16,000 American submariners who went on patrol during World War II, 3,500 never returned. A 22% casualty rate, the highest of any American service branch. But those men accomplished what no other force could accomplish. They destroyed over half of all Japanese shipping losses during the war, 5 million tons of merchant ships, 540,000 tons of naval vessels, over 1,400 Japanese ships sent to the ocean floor. The Mark 14 torpedo that had been useless in December 1941 became one of the most effective weapons in the Pacific War. It remained in service until 1980, nearly 40 years. The fixes implemented in 1943 proved so successful that the torpedo needed no major redesign for 4 decades. But the 2 years lost to bureaucratic obstruction and inadequate testing remain one of the great tragedies of American naval warfare. If the Mark 14 had worked properly from the beginning, Japan's merchant marine would have collapsed by 1943. The war might have ended a year earlier. Thousands of American lives might have been saved. Hundreds of thousands of Asian civilians who died from Japanese occupation might have survived. Admiral Charles Lockwood never received full credit during his lifetime for forcing the torpedo fixes. He was awarded the Distinguished Service Medal. He was promoted to Vice Admiral. But the dramatic surface battles at Guadalcanal received more attention. The carrier battles at Midway and Philippine Sea were celebrated in newspapers and newsreels. Submarine warfare remained the silent service. Few Americans knew what was happening beneath the Pacific surface. Lockwood died on June 6, 1967. He was buried at Golden Gate National Cemetery alongside Admirals Nimitz, Spruance, and Turner. His legacy was preserved in the submarines he commanded and the men he led. The submariners called him Uncle Charlie. He had fought for them. He had believed them when the Bureau of Ordnance didn't. He had conducted unauthorized tests to prove they were right. He had risked his career to fix weapons that were killing American sailors and allowing Japanese ships to escape. The Japanese never knew that American torpedoes had been fixed. They never understood that the submarine threat, which had been manageable in 1942, had become existential by 1944. They responded too slowly, with too little. By the time they recognized the scale of the threat, their merchant fleet was already doomed. American submarines with working torpedoes had sunk everything worth sinking. The Mark 14 torpedo scandal stands as proof that technological superiority means nothing without proper testing. That bureaucratic arrogance can cost lives. That admitting mistakes quickly saves more lives than defending failed systems. And that sometimes the most important battles aren't fought with weapons, but with persistence against institutional resistance. Commander Daspit's patrol on Tinosa was the breaking point. His meticulous documentation of 13 torpedo failures against a stationary target provided irrefutable proof that could not be dismissed. His decision to save one torpedo for analysis gave engineers the evidence they needed. His willingness to risk his career by reporting complete failure led to the fixes that turned the submarine campaign around. The Japanese never knew that on July 24, 1943, their largest tanker survived an attack that should have killed her. They never knew that her survival exposed the last critical flaw in American torpedoes. They never knew that within 2 months, American submarines would begin carrying weapons that actually worked. By the time they realized American torpedoes had become deadly reliable, it was too late to save their merchant fleet. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.